Hello everyone, I'm your friend inside XO. I am back. After the crates from the railway system, I'm going to go to a new tech company. But before I go to there, I was asked to learn a new technique, which was called GraphQL. So what it is, GraphQL actually. It says that it can describe your data. It can ask for what you want and get a predictable results. Alright, it's probably just a language for database or kind of stuff like that. Alright, let's get started. Because GraphQL is a communication pattern, there are many tools to help you get started working which support GraphQL in all sorts of languages. And for me, my career is related to the Python, so I won't choose other programming languages. Alright, if we want to get started into this, we will have to install this first. Alright, now I already created a new directory for this learning, so let's get started. First, we will have to install this library. Okay, after that, let's just copy those codes into our Python script. Let's have a look at this. First, it defines a query class, and it was inherited from this object. Then it says hello equal to graphing.string m equal to this default value equal to word, and it defines a function called resolve the hello self info lamp, and it returns the hello plus lamp, and the schema graph schema equal to query equal to this class. Then it uses schema that execute with hello here, and in the end it receives hello. It seems to be interesting, but I don't know how it will be if we run it. Oh my god, we get the result even if I do not think I have installed any database on my computer. I still could be able to run those codes. It's amazing. What kind of stuff really happened inside of that? So anyway, this is just let's say it's a library for doing some operations for the GraphQL. Here it is repository. Let's give it a start. And after that, let's read some documents here. Graphene is an opinionated Python library for building GraphQL schemas or types fast and easily. It's easy to use. Graphene helps you use GraphQL in Python without effort. Relay. Graphene has built-in support for relay. Data agnostic. Graphene supports any kind of data source, SQL, Digital SQL, Archme, NoSQL, custom Python objects, and so on. We believe that by providing a complete API, you could plug Graphene anywhere your data lives and make your data available to GraphQL. But it still cannot answer me what is GraphQL. That was interesting. Let's hit the nerd button. Here we go. Introduction to GraphQL. GraphQL is a query language for your API and a server-side runtime for executing queries by using a type system you define for your data. GraphQL isn't tied to any specific database or storage engine and is instant backed by your existing code and data. Whoa, that's amazing. So it doesn't really rely on any specific database software. Instead, it's just the pure codes and data of your varied programming language. A GraphQL service is created by defining types and fields on those types, then writing functions for each field on each type. For example, a GraphQL service that tells us who the login user is me, as well as that user's name might look something like this. So here we got a type of query, and for this type, it got one field, me, with a user, and the user is another class or object, I don't know, maybe another type. And for that type, it got two different fields. The first one is the ID, and the ID is here probably a number or another type. And for the len, it's quite clear that it is a string. So it's somehow it's a language for define the data structure or something like that, along with functions for each field on each type. Function query me. For this function, it receives the request and it returns the request that user. And for another function, the user len, it takes the user as the input and it will return the user that get the len. It's just an abstract for the for the data structure defining and the operations defining. Once a GraphQL service is running, typically at a URL on a web service, it can receive GraphQL queries to validate and execute. A received query is first checked to ensure it only refers to the types and fields defined, then runs the provided functions to produce a result. It's kind of difficult to understand. Let's read it again. Once a GraphQL service is running, typically at a URL on a web service, it can receive GraphQL queries to validate and execute. A received query is first checked to ensure it only refers to the types and fields defined, then runs the provided functions to produce a result. For example, the query, something like this, could produce the Johnson result of this. Learn more about GraphQL, the query language, type system, how the GraphQL service works, as well as best practices for using GraphQL in the articles written in this section. They help you solve common problems. So it seems like this is just the beginning, and if we want to master this stuff, we have to go to the next part. So let's go to there. Queries and mutations. On this page, you will learn in detail about how to query a GraphQL server. Fields. At its simplest, GraphQL is about asking for specific fields on objects. Let's start by looking at a very simple query and the result we get when we run it. So for this kind of table, I probably just want to tell us one fact is that if you give the, if the server a string like this, it will return you a JSON file like this. You can see immediately that the query has exactly the same shape as the result. This is essential to GraphQL because you always get back what you expect, and the server knows exactly what fields the client is asking for. The field len returns a string type. Here it is the len. In this case, the len of the main hero of Star Wars R2-D2. Oh, one more thing. The query above is interactive. That means you can change it as you like and see the new results. Try adding an appears in field to the hero object in the query and see the new result. Okay, let's try to add such a field here. Oh, here you can see the results just get it back. So this is amazing. It at least shows us that the GraphQL could be running on the browser or with the JavaScript programming language. So after we added this field appears in, and it will immediately returns us the results that we want. It's cool. In the previous example, we just asked for the len of our hero, which returned a string. But fields can also refer to objects. In that case, you can make a sub-selection of fields for that object. GraphQL queries can traverse related objects and their fields, letting clients fetch lots of related data in one request instead of making several round trips as one would need in a class REST architecture. Yeah, I agree with that. Because the REST architecture, it's too annoying. You have to define a lot of interface, application interface. That's quite boring. So as you can see here, we just defined another data structure or query command or something like that. So after the hero, we have defined another one, friends with a len, and on the results set, we say hero with a len and with the friends, and for the friends, it's just another list of len. Okay, that's great. Note that in this example, the friends field returns an array of items. GraphQL queries looks the same for both single items or lists of items. However, we know which one to expect based on what is indicated in the schemas. So for those codes, they are called schemas. Arguments. If the only thing we could do was traverse objects and their fields, GraphQL would already be a very useful language for data fetching. But when you add the ability to pass arguments to fields, things get much more interesting. So it's kind of like a programming language. Alright. So for this code, for this pattern, or for this schema, what the results we could get is data. The human returns you the len and the height, where the ID equal to 1000. I guess that's the meaning of all those codes. I don't know. Let's read on. In a system like REST, you can only pass a single set of arguments, the query parameters and URL segments in your request. But in GraphQL, every field and the listed object can get its own set of arguments, making GraphQL a complete replacement for making multiple API fetches. You can even pass arguments into a scanner field to implement data transformations once on the server instead of on every client separately. Well, I have no idea about that. Let's just read it again. In a system like REST, you can only pass a single set of arguments, the query parameters and URL segments in your request. But in GraphQL, every field and listed objects can get its own set of arguments, making GraphQL a complete replacement for making multiple API fetches. You can even pass arguments into scanner fields to implement data transformations once on the server instead of on every client separately. Okay, let's read it. Let's read the code here. Human with ID equal to 1000 with the same stuff, but with the height it got a new arguments. Unite equal to foot. And the data, what is the data we got? We got the data human lamb equal to this, the height equal to this. So what's the difference between this one and the previous one? As you can see, the previous one it's a different number. It's a smaller number. It's probably a different unit in a different unit. But for the second one in here, it's another number. Even if they are the same person, but they get a different number, so it's probably a different unit here. So arguments can be of any different types. In the above example, we have used an enumeration type, which represents one of a finite set of options. In this case, units of length, either matter or foot. GraphQL comes with a default set of types, but the GraphQL server can also declare its own custom types as long as they can be serialized into your transport formats. As long as they can be serialized. Okay, I know what kind of type could be serialized. For example, the integer or the string. I length says, if you have a sharp I, you may have noticed that since the result object fields match the length of the field in the query, but don't include arguments, you can't directly query for the same field with different arguments. That's why you need analysis. They let you rename the result of a field to anything you want. Wait a minute, what is alias? It's probably an alternative word for a word.
Aliases.
Aliases. If you have a sharp I, you may have noticed that since the result object fields match the length of the field in the query, but don't include arguments, you can directly query for the same field with different arguments. That's why you need aliases. They let you rename the result of a field to anything you want. So here we can say at the right side, at the left side, we get the code or the query codes. Empire hero to the hero with where the episode equal to empire, and we want to get the length of the hero. And the second one is jolly hero. Hero is some kind of stuff like that. And on the result on the right side, we get the data empire hero. It's the same length, and the length equal to this. And here we get the jolly hero, and the length equal to this. Do you know what I am thinking right now? My understanding, I guess we are using the hero. We assume that there's a field stored in our database which called hero. But we want to get two different kind of hero. One type of the hero is empire hero. Another type of hero is jelly hero. And for each hero, it get different episode. So we can define a function like this, and we for doing this, we could get two different results, the two different heroes. So it's just a way to get different types of data from the same type of data from our database. Anyway, that's a case. Fragments. Oh my god, what is fragments? Fragments. I know what is fragments, but I do not know what's the meaning of the fragments in the GraphQL inside of the GraphQL framework. Let's say we have a relatively complicated page in our app, which lets us look at two arrays side by side along with their friends. You can imagine that such a query could quickly get complicated because we would need to repeat the fields at least once, one for each side of the comparison. That's why GraphQL includes reusable units called fragments or fragments.
Fragment.
Alright, fragments. Fragments let you construct a set of fields and then include them in queries where you need to. Here's an example of how would you solve the above situation using the fragments technique. Here we go. Let's say, where's the fragment? Okay, here it is a fragment. The fragment got a len on comparison fields on character. Len appears in friends len, and above it's let's say what's the len? It's aliases. And for those codes, as you can see here, we get a very short codes. But for this code, it returns as a long series of data, JSON data. That's very complicated. To be honest, I have no idea about that. You can say how the above query would be pretty repetitive if the fields were repeated. The concept of fragments is frequently used to split complicated application data requirements fragments into smaller chunks, especially when you need to combine lots of UI components with different fragments into one initial data fetch. What? You can say how the above query would be pretty repetitive in the fields were repeated. The concept of fragments is frequently used to split complicated application data requirements into smaller chunks, especially when you need to combine lots of UI components with different fragments into one initial data fetch. Well, let's have a look at those codes. The first one is the len, and for the len, for each friends you get the len, for the right comparisons you get the len, and for the friends you get the len, and the appears in, it only appears in the right comparison and the left comparison, and for the friends they don't have it. And then for the friends it only got the len in here. So if you look carefully about the data that we get from those on the right side, you can see the friends it's just a subfield of the left comparison or the right comparison, and for the left or right comparison it's defined in here, left comparison, the right comparison. And for the data, we didn't actually define the data structure in here. Actually, we defined another one in here, fragments, and we lam it to compression fields. And after the definition of the fragments, we copy this lam into or under the data here. So in this case, instead of writing those codes twice, we can only just pass the len of that fragments into under the two field, and it's done. So in this way, we could somehow construct a very complicated requirements for our database. Let's go on. Here we go. Using variables inside fragments. It is possible for fragments to access variables declared in the query or mutation. Say variables. It is possible for fragments to access variables declared in the query or mutation. So where's the variable? As you can see, I guess this is for this one, this kind of like a variable. So if we have defined a query in here with the variable or arguments, for example, the first is an integer equal to 3, then we could pass that arguments or variable to the fragments, and all we need to do is what? Let's say it's just another another function. I guess this is also a function. Then we just pass that variable into the first argument. Then it's done. For this case, we could also get the results back. And the operation len. Up until now, we have been using a shorthand syntax where we augment both the query keyword and the query len. But in production apps, it's useful to use these to make our code less ambiguous. Right. Here's an example that includes the keyword query as operation type and hero len and friends as operation name. Well, it's kind of getting complicated. I just pause for a while and have a rest. Then I will come back and continue to learn this framework. Alright, welcome back. Let's go on. Operation name. Up until now, we have been using a shorthand syntax where we augment both the query keyword and the query len. But in production apps, it's useful to use these to make our code less ambiguous. Here's an example that includes the keyword query as operation type and hero len and friends as operation name. So query is a keyword and this len is an operation name. The operation type is either query, mutation, or subtraction that describes what type of operation you are intending to do. The operation type is required unless you are using the query shorthand syntax, in which case you can supply a len or variable definitions for your operation. The operation name is a meaningful and explicit len for your operation. It is only required in multi-operation documents, but its use is encouraged because it is very helpful for the debugging and server-side logging. When something goes wrong, you see errors either in your network logs or the logs of your GraphQL server. It is easier to identify a query in your database by len instead of trying to decipher the contents. Think of this just like a function name in your favorite programming language. For example, in JavaScript, we can easily work only with an anonymous. I guess that's a pronunciation. Anonymous. Okay. Let's say, for example, in JavaScript, we can easily work only with an anonymous function. But when we give a function a len, it's either to track it down, debug, or code, and log when it's called. In the same way, GraphQL query and mutation names along with fragment names can be a useful debugging tool on the server side to identify different GraphQL requests. Let's go on. Variables. So far, we have been writing all of our arguments inside the query string, but in most applications, the arguments to fields will be dynamic. For example, there might be a drop-down that lets you select which Star Wars episode you are interested in, or a search field, or a set of filters. It won't be a good idea to pass these dynamic arguments directly in the query string, because then our client-side code would need to dynamically manipulate the query string at runtime and serialize it into a GraphQL specific format. Let me read it again. I couldn't follow it. It won't be a good idea to pass these dynamic arguments directly in the query string, because then our client-side code would need to dynamically manipulate the query string at runtime and serialize it into a GraphQL specific format. Instead, GraphQL has a first-class way to vector dynamic values out of the query and pass them as a separate dictionary. These values are called variables. When we start working with variables, we need to do three things. 1. Replace the static value in the query with variable len. Declare the variable len as one of the variables accepted by the query. 3. Pass variable len the value in the separate transport-specific, usually Johnson variables dictionary. So here's what it looks like all together. Declare the static value in the query with variable len. Here it is. And declare the variable len as one of the variables accepted by the query. Then pass variable len with that value in a separate transport-specific, usually Johnson variables dictionary. So this is a Johnson variable dictionary. Now, in our client side, in our client code, we can simply pass a different variable rather than needing to change the values inside of the query code. So it helps, especially if you want to dynamically change this stuff. You could just handle it with your favorite language, just how you do with a normal Johnson file. Variable definitions. The variable definitions are the part. The variable definition are the part that looks like this in the query above. It works just like the argument definitions for a function in a typed language. It lists all of the variables prefixed with this symbol, US dollar symbol. It's probably have a len. Dollar. Yeah, that's a len. Followed by the type. In this case, episode, this is the type. Alright. All declared variables must be either scanners, enamels, or input object types. So if you want to pass a complex object into a field, you need to know what input type that matches on the server. Learn more about input object types on the schema page. Variable definitions can be optional or required. In the case above, since there isn't an this symbol next to the episode type, it's optional. But if the field you are passing the variable into requests a non arguments, then the variable has to be required as well. To learn more about the syntax, it's useful to learn the GraphQL schema language. Oh, it's even got a programming. It's not a programming language. It's just a language for defining the data structure. Default variables. Default values can also be assigned to the variables in the query by adding the default value after the type declaration. Default variable. Oh, here's how it defines the default variable. So it's very similar to the Python. Okay, let's go on. Directives. What is that? Directives. Alright. Directives. We discussed about how variables enable us to avoid doing manual string interpolation to construct dynamic queries. Passing variables in arguments solves a pretty big class of these problems, but we might also need a way to dynamically change the structure and the shape of our queries using variables. For example, we can imagine a UI component that has a summarized and detailed view where one includes more fields than the other. For example, we can imagine a UI component that has a summarized and detailed view where one includes more fields than the other. Okay. So here's the query, the len, and it got two basically variables. you get two variables. The first variable type is episode. The second variable type is a blown value. It's a blown. Then the hero. Let's look at the hero. So let's say whether it will include the friends are totally depends on whether it includes with friends. So if with friends equal to true, or yeah, if it's true, then it will include the friends. Otherwise, it will not. So if we change this value to true, you can say to the right side, the results inside of those results, you can say we get the friends, a list of friends. Awesome. So it's kind of like a programming language now. Okay, let's go on. Mutations. All right. As you know, if you have ever learned the Vue.js framework, you would know such a keyword called mutation, or it's a concept about that front-end framework. It says that every operations that needs to change the storm's value, it has to be inside of the mutation functions. So here it's the same idea. Most discussions of GraphQL focus on data fetching, but any complex data platform needs a way to modify server-side data as well. In RESTful API, any request might end up causing some side effects on the server. But by conversion, it's suggested that one doesn't use GET requests to modify data. Yeah, normally we would use a POST request to modify the data. GraphQL is similar technically. GraphQL is similar. Technically, any query could be implemented to pass a data write. However, it's useful to establish a conversion that any operations that cause writes should be sent explicitly with a mutation function. Just like in queries, if the mutation field returns an object type, you can ask for listed fields. This can be useful for fetching the new state of an object after an update. Let's look at a simple example about the mutation. So mutation, it's just a type of operations, and here's the operation name. Create a review for episode, and for this operation or for this function, it gets two arguments. The first one is episode. The second one is a review. They are both required, so that's why they have used this symbol. Okay. Then let's go on, and let's say for this one, it's also got two variables, episode and review. And for the chunks file or for the variable for variables, we have defined it in here. The EP equal to JEDI. The EP here are the same thing in here. I wasn't quite understanding about this. It seems like it's still a get function. It doesn't really modify anything. Note how create review field returns the stars and commentary fields of the newly created review. What is that? This is especially useful when mutating existing data. For example, when incrementing a field, since we can mutate and query the new value of the field with one request. So I guess this point is quite easy for understanding. So whenever you modify an existing record or existing data, you will get the modified data back, and all you have to do is to request it once. Yeah, it's quite useful. You might also notice that in this example, the review variable we passed in is not a scanner. Yeah, it's an object here. It's an input object type, a special kind of object type that can be passed in as an argument. It can be passed in as an argument. Oh, I got it. For example, here we got the stars and the commentary. It's just another representation of the two fields in here. So actually, for this function, it's indeed did a modification about our database or server-side data. The multiple fields in mutations. A mutation can contain multiple fields, just like a query. There's one important distinction between queries and mutation, other than the len. While query fields are executed in parallel, while the mutation fields runs in series. This means that if we send two increment credits mutations in one request, the first is guaranteed to finish before the second one. Okay, that's quite safe. Alright, I'm going to pass again and have a drink of water. Alright, hello guys, welcome back. Let's go on. Inline fragments. Like many other type systems, GraphQL Schemas include the ability to define interfaces and U9 types. If you are querying a field that returns an interface or a U9 type, you will need to use inline fragments to access data on the underlying concrete type. It's easiest to say an example. Well, why here we get 3 dots. In this query, the hero field returns the type character, which might be either a human or Android, depending on the episode argument. In the direct selection, you can only ask for fields that exist on the character interface, such as len. To ask for a field on the concrete type, you need to use an inline fragment with a type condition, because the first fragment is labeled as something like this. The primary function field will only be executed if the character returned from hero is of the draw type. Similarly, for the height field for the human type, named fragments can also be used in the same way, since a lambda fragment always has a type attached. To be honest, I have no idea about this. What is the scene they are trying to tell us? Like many other type systems, GraphQL schemas. Alright, GraphQL schemas include the ability to define interfaces and U9 types. If you are querying a field that returns an interface or a U9 type, you will need to use inline fragment to access data on the underlying concrete type. It's easiest to say an example. So for the hero, let's say what's inside of that block, the len. Okay, probably this is like a judgment or something like that. So it may return you the height, or it may return you the primary function. And for this case, it returns the primary function. But what's the meaning for this sentence? What it means? In this query, the hero field returns the type character, which might be either a human or drawed, depending on the episode argument. So it's depending on this argument, and to be specific, depending on this or this. In the direct selection, you can only ask for fields that exist on the character interface, such as len. To ask for a field on the concrete type, you need to use an inline fragment with a type condition. Because the first fragment is labeled as this on draw, the primary function field will only be executed if the character returned from hero is of the draw type. It's still kind of confusing, but let's skip it, because we will probably never use it later or in the future, because it's just a part of this framework. Met fields. Given that there are some situations where you don't know what type you will get back from the GraphQL service, you need some way to determine how to handle that data on the client. GraphQL allows you to request type len, a meta field, at any point in a query to get the len of the object types at that point. So let's say this is probably a function and it gets an text, right? Kind of like that. In the above query, search returns a U9 type that can be one of 3 options. It would be impossible to tell apart the different types from the client without the type len field. Let's read this again. Given that there are some situations where you don't know what type you will get back from the GraphQL service, you need some way to determine how to handle the data on the client. GraphQL allows you to request type len, a meta field, at any point in a query to get the len of the object type at that point. So it says that yes, it will return you the results that you need, for example the len, but it will also return you the type len. For example, this is how they determined what kind of data would be returned to you, and it will just give you a result that has the type len. For example, the human, here is the human, the draw, the starship, because that's how they determined for the return value. And if you want such a data to be returned, all you have to do is add this line of code to your query code, and that's it. Then we come to another part of this framework. It's called schemas and types. Schemas. Alright. Schemas and types. On this page, you will know all you need to know about the GraphQL type system and how it describes what data can be queried. Since GraphQL can be used with any backend framework or programming language, we will stay away from implementation-specific details and talk only about the concepts. The type system. If you have seen a GraphQL query before, yeah, I have seen that on the previous page, you know that the GraphQL query language is basically about selecting fields on objects. So for example, in the following query, yeah, I get it. Then we start with a specific road object. This is a road object, this symbol, the 2 symbol. Then we select the hero field on that. So we here we got a hero. For the object returned by hero, we select the len and appear in fields, 2 keyword or 2 keys. Because the shape of a GraphQL query closely matches the result, you can predict what the query will return without knowing that much about the server. But it's useful to have an exact description of the data we can ask for. What fields can we select? What kinds of objects might they return? What fields are available on those sub-objects? That's where the schema comes from or comes in. Every GraphQL service defines a set of types, which completely describes the set of possible data you can query on that service. Then, when queries come in, they are validated and executed against the schema. Type language. GraphQL services can be written in any language. Since we can't rely on a specific programming language syntax like JavaScript or anything else to talk about GraphQL schemas, we will define our own simple language. We will use the GraphQL schema language. It's similar to the query language and allows us to talk about GraphQL schemas in a language agnostic way. So object types and fields. The most basic components of a GraphQL schema are object types, which just represent a kind of object you can fetch from your service and what fields it has. In the GraphQL schema language, we might represent it like this. So here we got a type of character. We get the field len and the field type or the variable type, whatever. The language is pretty readable, but let's go over it so that we can have a shared vocabulary. Character is a GraphQL object type, meaning it's a type with some fields. Most of the types in your schema will be object types. Len and appears in. Len and appears in are fields on the character type. That means that len and appears in are the only fields that can appear in any part of a GraphQL query that operates on the character type. String is one of the built-in scanner types or just types in any programming language. It's the same thing, I guess. These are types that resolve to a single scanner object and can have sub-selections in the query. We will go over scanner types more later. A string with a symbol of this means that the file is non-nullable. So in other words, if you give it a none or if you ignore it, something will go wrong. Meaning that the GraphQL service promises to always give you a value when you query this field. In the type language, we will represent those with an exclamation mark. Oh, this is a word that I have said before.
Exclamation.
Exclamation. Alright, exclamation. Episode represents an array of episode objects since it is also non-nullable. You can always accept an array with zero or more items when you query the appears in field. And since episode with the exclamation mark is also non-nullable, you can always expect every item of the array to be an episode object. Now you know what a GraphQL object type looks like and how to read the basics of the GraphQL type language. Then let's go on. The arguments. Every field on a GraphQL object type can have 0 or more arguments. For example, the length field below. So we got what? Alright, it's just a field. All arguments are length. Unlike languages like JavaScript or Python, where functions take a list of ordered arguments, all arguments in GraphQL are passed by length specifically. In this case, the length field has one defined argument, which is a unite. In other words, all its arguments, for each of them, they got a specific length. The query and mutation types. Most types in your schema will just be normal object types, but there are two types that are special within a schema. Two types, basically. The first type is the query, and the second one is a mutation. Every GraphQL service has a query type and may or may not have a mutation type. These types are the same as a regular object type, but they are special because they define the entry point of every GraphQL query. So if you see a query that looks like something like this, that means that the GraphQL service needs to have a query type with hero and drawed fields. Wait a minute, let's read it again. Every GraphQL service has a query type and may or may not not have a mutation type. These types are the same as a regular object type, but they are special because they define the entry point of every GraphQL query. So if you see a query that looks like this, that means the GraphQL service needs to have a query type with arrow and drawed fields. So I guess they probably are doing the same thing, or they are the same thing. For now, I have no idea about how to use the GraphQL yet, with a specific programming language. It's just some abstract concepts for now. Scanner types. A GraphQL object type has a len and fields, but at some point, those fields have to resolve to some concrete data. That's where the scanner types come in. They represent the leaves of the query. In the following query, the len and appears in fields will solve to scanner types. We know this because those fields don't have any subfields. They are the leaves of the query. In other words, they are in the bottom of the architecture or hierarchy. So they will definitely be some default types. For example, the integer or float or string or boolean or ID. The ID scanner type represents a unique identifier, often used to refetch an object or as the key for a hash. The ID type is serialized in the same way as a string. However, defining it as an ID signifies that it is not intended to be human readable. Alright, it's not human readable. In most GraphQL service implementations, there is also a way to specify custom scanner types. For example, we could define a data type. So if you ask me what is a scanner, I will probably just tell you it's another word for variable. So for this sentence, it just defines a variable, and the name of that variable is data. Then it's up to our implementation to define how that type should be serialized, deserialized, and validated. For example, you could specify that the data type should always be serialized into an integer timestamp, and your client should know to expect that format for any data fields. Enumeration types, also called enums. Enumeration types are a special kind of scanner that is restricted to a particular set of allowed values. This allows you to 1. Validate that any arguments of this type are one of the allowed values. 2. Communicate to the type system that a field will always be one of a finite set of values. Here's what an enum definition might look like in the GraphQL Schema language. So it's probably I have no idea about this. This means that wherever we use the type episode in our schema, we expected it to be exactly one of this or this or this. It can be any one of them, and it will not be something else. It's just one of them. Note that GraphQL service implementations in various languages will have their own language-specific way to deal with enums. In languages that support enums as a first-class citizen, the implementation might take advantage of that. In a language like JavaScript with non-enum support, these values might be internally mapped to a set of integers. However, these details don't leak out to the client. In other words, the client doesn't know anything about that. It's just about the server, how you implement such a thing. Okay, let's have a rest and go on. Alright, let's go on. Lists and nom object types, scanners, and enums are the only kinds of types you can define in GraphQL. When you use the types in other parts of the schema or in your query variable declarations, you can apply additional type modifier that affects validation of those values. Let's look at an example. Here we get an example. Here we are using a string type and marking it as nom by adding an mark after the type len. The nom type modifier can also be used when defining arguments for a file or field, which will cause the GraphQL server to return a validation error if a nom value is passed as that argument, whether in the GraphQL string or in other variables. So here, if you pass a nom to the ID, it will cause an error. But if I remove this mark, everything would be fine. If I add that mark again, we'll get an error. So that's the basic idea about that. Let's work in similar way. We can use a type modifier to mark a type as a last. Here we go. We get this to represent the last. So for this case, this last could be none, could be something like this. But its element will never be a nom if it is case, an error would be appeared. Let's hurry. We don't have much time for this. Interfaces. Like many type systems, GraphQL supports interfaces. An interfaces is an abstract type that includes a certain set of fields that a type must include to implement the interface. For example, you could have an interface character that represents any character in the Star Wars trilogy. So here we get an interface. This means that any type that implements character needs to have these exact fields with these arguments and return types. For example, here are some types that might implement the character. We get the first character and the second character with different lengths. The first one is called human, and the second one is called droid, and they have different fields inside of them. You can say that both of these types have all of the fields from the character interface, but also bring in extra fields, total credits, starships, and primary function, and that are specific to that particular type of character. Interfaces are useful when you want to return an object or set of objects, but those might be of several different types. For example, note that the following query produces an error. Yeah, because the primary function haven't been declared or implemented. Yeah, that's the thing. Let's go on. Union types. Union types are very similar to interfaces, but they don't get to specify any common fields between the types. Wherever we return a search result type in our schema, we might get human, droid, or starship. So any one of them. Note that members of a union type need to be concrete object types, so you can't create a union type out of interfaces or other unions. Okay, let's go to the next one. Input types. So far, we have only talked about the passing scalar values like enums or strings as arguments into a field. But you can also easily pass complex objects. This is particularly valuable in the case of mutations where you might want to pass in a whole object to be created. In the GraphQL Schema language, input types look exactly the same as regular object types, but with the keyword input instead of type. Yeah, I was kind of lost because now I have something else to do than this. Okay, let's just stop in here and I'll come back. Alright guys, let's go on. Here the input types, we already talked about that. It's just some types. Then let's go to the next one, validation. It's probably the last one, I don't know. For the validation, by using the type system, it can be predetermined whether a GraphQL query is valid or not. This allows the server and client to be efficiently communication. For our Star Wars example, the file this.js contains a number of queries demonstrating various invalidates, and is a test file that can be run to exercise the reference implementation's validator. To start, let's take a complex valid query. This is a nested query similar to an example from the previous section, but with the duplicated fields factored out into a fragment. You know what? I do not think that there has any validation kind of stuff. But one thing we could know is that if we give it a wrong query command, it will raise an error. That's the only thing that we know. Let's go to the next one. Execution. After being validated, a GraphQL query is executed by a GraphQL server, which returns a result that mirrors the shape of the requested query, typically as JSON file. GraphQL cannot execute a query without a type system. Let's use an example type system to illustrate executing a query. This is a part of the same type system used throughout the examples in those articles. So at the first, we have defined two types. Basically, those codes, they are all types definitions. Then we define the query format or something like that. Root fields and resolvers. At the top level of every GraphQL server is a type that represents all of the possible entry points into the GraphQL API. It's often called the root type or the query type. In this example, our query type provides a field called human, which accepts the argument ID. The resolver function for this field likely accesses a database and then then constructs and returns a human object. So we have defined a query, and for this query we get a human. This human, it needs a few arguments, and for this I don't know how to say it. You can think it as a function, and for this function it will return you something. The object, the previous object, which for a field on the road query type, is often not used. So this is not always be used. ARGS, the arguments provided to the field in the GraphQL query, contains a value which is provided to every resolver and holds important contextual information like the currently logged in user or access to a database. Info, a value which holds field-specific information relevant to the current query as well as schema details. Asynchronous resolvers. Let's take a closer look at what's happening in this resolver function. Yeah, that's also what I want to know. The context is used to provide access to a database, which is used to node the data for the user by the ID provided as an argument in the GraphQL query. Since loading from a database is an asynchronous operation, this returns a promise, and in JavaScript, promises are used to work with asynchronous values, but the same concept exists in many languages, often called futures, asks, or deferred. When the database returns, we can construct and return a new human object. Notice that while the resolver function needs to be aware of promises, the GraphQL query does not. It simply expects the human field to return something which it can then ask for the land. Travel resolvers, we can even just return some part of the value, or if you want, you can also use the map. We have already seen a bit of what happens when a field returns a list of things with the appears in field above. It returns a list of enumerated values, and since that's what the type system expected, each item in the list was coerced to the appropriate enumerated value. What happens when this field is resolved? The resolver for this field is not just returning a promise, it's returning a list of promises. GraphQL will wait for all of these promises concurrently before continuing, producing the result. As each field is resolved, the resulting value is placed into a key value map with the field len as a key and the resolved value as a value. This continues from the bottom left fields of the query all the way back up to the original field on the road query type. Collectively, these produce a structure that mirrors the original query, which can then be sent, typically as Johnson, to the client which we requested it. Yeah, this is just what we have learned before. Okay, this is probably the last part of those articles. So yeah, introspection. What is it?
Introspection.
Introspection, the examination or observation of one's own mental and emotional process. That's a difficult word. It's often useful to ask a GraphQL schema for information about what queries it supports. GraphQL allows us to do so using the introspection system. For our Star Wars example, the field Star Wars introspection test contains a number of queries demonstrating the introspection system, and is the test field that can be run to exercise the reference implementation's introspection system. We designed the type system so we know what types are available, but if we didn't, we can ask GraphQL by querying the schema field always available on the row type of a query. Let's do so. Here I just asked for the schema with this keyword, and to be honest, we probably do not know the types for now. But the server or this framework returns us a bunch of different types with different lambs. Maybe this is just means the type lamb, so it got different types. For example, the query, the string, the ID, mutation, and so on. Well, that's a lot of types. What are they? Let's grab them. Query, character, human, episode, road. These are the ones that we define in our type system. String, boolean. These are built-in scanners or variable types. And all those different things like this one. These are processed with a double underscore, indicating that they are part of the introspection system. Now let's try and figure out a good place to start exploring what queries are available. When we designed our type system, we specified what type all queries would start at. Let's ask the introspection system about that. Here it's asked for the query type, and it returns something like this. And that matches what we said in the type system section, that the query type is where we will start. Note that the lambing here was just by conversion. We could have lambed or query type anything else, and it still would have been returned here had we specified it was the starting type for the queries, lambda query. So it's a useful conversion. It's just something like this. It's useful for an object to know what fields are available. So let's ask the introspection system about the drawed. So for type, if the lamb of that type is called drawed, then we return the lamb, the fields. Alright, I think that's the scene. That's the learning for today. Because for the next, we need to read the best practices, but it's not necessary for now because this is the first day and the first time for me to learn the GraphQL. All I need is to have a basic understanding about this framework, so I doesn't really necessarily need to get deep into this framework. So that's today's learning. I will see you guys in the next video. Bye.